Hello students, today we are going to discuss about the motion chapter number 7, 9 CBSE. So in this motion chapter we are going to deal with some terms, means distance, displacement, velocity, speed, this kind of terms. We will know about those, but before that we need to know what is motion means nothing but the movement of an object, right? Like this microphone, this mic is now fixed means not in motion. Like my hand, this hand is in motion means what? The movement of this object. So the movement of any object is known as its motion. So it according to the type of movement we can divide the motion into several types. Okay, like when this hand or this pen is moving like this or like this, then it is along a straight line, like so when it is along a straight line, straight path, then straight line motion is happening. So it is also known as linear motion. Okay, it is also known as linear motion or rectilinear motion. When this pen is moving like this along a circular path, when it will rotate, then it will be called as circular motion. Okay, another thing, like this pen is rotating about itself, right? About a point it is moving, and that point is within this pen. So this kind of motion is known as rotational motion. Like this is rotating now, this kind of motion is known as rotational motion. And also you know about the pendulum. In class 8 you have learnt about the pendulum. So pendulum basically oscillates like this. Okay, it moves like this, means continuously it traces its original path one by one it, so it repeats its path. So this kind of motion is known as what? Is known as oscillatory motion. So circular motion, rectilinear motion, rotational motion, this kind of a lot of motions are there, but our interest in this chapter number 7 class 9 is what? Is on linear motion, basically on linear motion, and some introductory part of the circular motion will come, but main focus will be on linear motion. So let's start our discussion, and before going to that discussion we have to say about some extra topic to, because sometimes some questions, some MCQ type questions may ask from that topic, so we have to cover that. So let's start with physical quantity, right? Physical quantity and type of physical quantities. So basically any physical quantity we can check that it has direction or not, it has a value or not. So obviously any physical quantity like mass, like density, like pressure, velocity, speed, anything it may be, but that physical quantity will have some value, right? So a physical quantity must have a value, but it is not necessary that it is having some direction. Okay, so value is present, it is confirmed, but nothing we can say about the direction. Okay, direction may be or may not be. So if some quantities, some physical quantities having some value as well as direction, those are called vector quantities. Okay, so values and direction, these two are present, are known as what? That is vector quantities. Like what are the examples? Example means like let's suppose an ant or an insect is here. Okay, now this is the now it is moving from this end to this end along a straight path. Okay, along a straight path it is moving. So it has a particular direction, that the ant is moving along this direction always, right? So also it has some value that this much of length it is traveling. Okay, so it is the value like 15 centimeter, 12 centimeter it is traveling, and also along which direction, along this direction. Okay, so value as well as direction is present. Similarly, if it, let us suppose that it is of 50 gram. Okay, let's suppose its mass is 50 gram. Now if I leave it from here, from this position, what will happen? It will drop, right? It will go downward. So now it is having some direction that after leaving it, it is going downward, right? Means it is having some value. What is that value? Value is 50 gram and it is going downward. So mass is not going downward. Okay, on this mass some force is acting. On this mass of 50 grams, some force is acting. This force is known as gravitational force. You all know, because our earth is attracting this pen, and this pen is going downward. This is why it is known as gravitational force, and the pulling is downward. So what is its value? We can calculate the amount of force given on this object, and also it has some direction. This is why it is physical quantity. Okay, this force is physical quantity and this force is a vector quantity. Why? Because it has value as well as direction. Okay, so this is a vector quantity. Now only if it holds some value but no direction, like only its mass is 50 gram, but along which direction we don't know. This we don't know about the direction. Okay, like time is going towards future, but still it is not a direction. Future is not a direction. Okay, so time is also a scalar quantity having only value. Okay, you can say that, sir, like the hands of the clock are moving clockwise direction, so obviously they might be having some direction, but no, those particular hand is having some direction, not of time. Okay, time like 6 am or 6 pm, after that it is 7 am or 7 pm, it is going, only value is changing, no such kind of direction. Okay, so no such kind of direction of time, only value is present in case of time. So what are the examples? So vector quantity, value and direction both are present. Like what are the examples? Examples are like force. Why I am saying this at first? Because you can understand that this pen is attracted by the earth with some force. This is why I am saying, and this force is acting downward, or as well as it is having some value. Okay, so force. And next is displacement. I am coming into this point. Displacement, like velocity, this kind of things is having, and weight also, this is having also some direction. And in case of value, only value means those are known as scalar quantities. Okay, scalar quantities. So scalar quantities, in case of scalar quantities, time is the first example I can take, then speed, then distance, and next pressure. So this mass also, pressure, mass. So this kind of things are the examples of scalar quantities. A lot of quantities are there. Okay, means volume is also a scalar quantity. A lot of examples are there of both scalar and vector quantities. Okay, we will discuss this later. So now let's come into the point. Means somehow some MCQ type questions may ask that this is scalar quantity or vector quantity. This is why I am saying these things. Okay, now so in this motion chapter we will learn about some terms, some new terms, like you know about distance, you know about the distance. but displacement is the new term for you. If you don't heard this, then obviously it is a new term, because it is it is not usually used, right? So distance and displacement, these are two terms, and these are almost similar. I am not saying similar and same, I am not saying about that, but almost similar. But distance, you know that it is having some value, only value, so it is a scalar quantity, it is a scalar quantity. And displacement on the other hand is what is the vector quantity. Okay, displacement is what kind of quantity? This is a vector quantity, is having some direction. I am coming into that point, how it is having some direction. Okay, so let's at first discuss about the distance and displacement. Let us consider this is a cottage. Okay, this is a cottage, and this is another building. This is another, let's suppose this is another building. Now there is a certain path to go to this building from this cottage. Okay, from this cottage we can go to this building via this path. So here this is a point, this is a point from which from we can consider it is a cottage, from which we are starting our movement and we are going to this building, right? We are going to this building. Now what is the fact? Fact is that I am going through this path. Okay, through this path, by any path it may be, means it may be like this kind of path, it may be like this kind of path, straight path, anything may be, it may be. So fact is that the distance means the path length, you know na, the odometer which is placed on the the front of the bike, right? Where how much kilometer, how much length is traveled is measured by that odometer. Okay, so odometer is what is used to measure the distance or path length traveled by the bike. So by using odometer we can calculate how much path length we are going. So this is basically what this is distance. Like from Howrah station to our Bankura station, like Bankura station to Howrah station we are trying to go. So at first we will move via auto or via bus to the Bankura station. Then from Bankura station we'll take train, and via train will not go straight, right? Train will go by following its track, and its track is not totally straight. You can see the map, this is not totally straight. So it is going by following its track only, which is not perfectly straight. So what is happening actually for that case? From Bankura to Howrah, the distance traveled by the train, distance means path length actually. So distance is what? Distance is the path length traveled by any object. Okay, so I am just writing path length traveled by any object, by any one, this may be the distance. So now you may ask me the question that, sir, we can also go from A point to B point by a straight route, right? Like a GT road, like GT road we can move. This is a straight path, we can move, right? So obviously we can move, no problem, and then this path length will be called distance. Okay, now what is the displacement then? Means where from the concept of displacement is coming. Just see, so from A point to B point we can reach by several paths, like this path, like this path, like a straight path, like this path. By any path we can reach from A to B, it is possible, right? But the shortest length or the minimum path length, when you are moving from A to B by straight road, it will be the simplest one and it will be the shortest one, shortest path. So that shortest path length or shortest distance is known as displacement. Okay, means when you are moving by this straight road, then that path is known as what? Displacement. So I can write down shortest distance or shortest path length. path length is known as displacement, displacement. So this is the concept of displacement, and generally displacement is denoted by S. Okay, but when you will calculate or you will go to the numericals, there might be a problem only with this concept. Means if I leave the concept of distance and displacement here, after thinking that you know all the things, then you will face a problem while calculating or while doing the numericals. Okay, so I have to go further more detailed into displacement. Distance is over, distance is very much simple, and concept of distance is almost over. Now during when we go to the numericals, then all the concepts will be clarified in case of distance. But for displacement we need to know two another terms, like from which point we are starting our journey. That point is known as starting point or initial point. Okay, so this A point is known as initial point or starting point. I know that starting point is simple because you know this term start, but initial point is mostly used term in physics, okay, in this kind of problems. So initial point is the starting point, and B point is what? B point is final point, or even you can say end point of the journey. So means shortest distance or shortest path length is known as displacement. It is fine, no problem about that. But fact is that some kind of questions may ask. I am giving you some example, means one example, just see. Let's consider that this one is our x-axis. This is starting from origin 0. Now this is marked 40 meter, this is marked 80 meter, this is marked 120 meter. This kind of markings are there, and O point, A point, B point and C point. If someone is saying that an object is moving or a car is moving from O point to C point, so only O to C when I am saying, then what is the value of displacement? Value of displacement is from initial point to final point distance from initial point to final point. So from O to C the distance is 40 plus 40 plus 40 means 120, right? 120 meter is the displacement. So for that case you have to look on the end point and starting point, or initial point and final point. Now let's make it some difficult, like from O point it is at first going to C, from O to C it is going, then again returning to B. So O to C at first it is going, then returning to B point. Means O to C, what is the distance? That is 120 meter. 120 meter is the distance traveled. This is the what? This is distance. Now from C to B, what is the distance from C to B? This gap is 40 meter. This distance is also 40 meter. 40 to 80, what is the difference? 40 meter. 80 to 120, what is the difference? 40 meter. Means 120 meter it is going from O to C, and he is returning from C to B by 40 meter. So 40 meter is the distance from C to B, right? From C to B it is 40 meter. So if someone asks you that over the whole journey from O to B via C, from O to B it is moving via C, for this case total distance will be the path length. Means from O to C you are going from O to C, by a bike or scooter, just think that you are going from O to C by bike or scooter, then petrol, then in odometer some reading will come. Okay, when you returning to C to B, then odometer reading will increase or decrease? Obviously increase, because further more distance it is traveling, further more path length it is traveling. So O to C reading is increasing, C to B reading is increasing. So path length, always think about the odometer in case of distance. Okay, so distance will be what? Distance will be the sum of 120 plus 40, means 160 meter. This is the distance. Now what is displacement? How you can calculate displacement? I have already said the about 2 points, initial and final points. See, the object was starting from O, and finally after it is going to C, no problem, no doubt, but final journey, finally it is stopping at the point B. After going to C, it is stopping at the point B, means B point is the final point. Okay, B point is the final point. So here initial to final distance between initial or starting point to final point distance, this is known as what? This is known as displacement. So you can calculate this OB distance. OB is the displacement, which is given by how much? Which is given by 80 meter. Now this is the first method by which you can easily calculate by the concept of final and initial point. And another concept you can also use here, that is the vector concept. Means I am not going into that much deep level, but by following the direction you can calculate. I am coming into that point, just see. So when you are going along positive x direction, it is positive, it is giving you positive value. So 120 meter you are moving along positive x direction, 120 meter you are moving along positive x direction. So you have to write plus 120 meter, because the movement is along positive x direction. Now when he or she is returning from the point C to B, then its direction is changing and opposite to that direction, means it is now, or he is now moving along negative x direction. It is now moving along negative x direction. So fact is that 40 meter it is moving along negative x direction, so it is minus 40 meter, right? So what is the value? What is the value? Value is 0 and 8. So 80 meter of positive sign it is moving. So what is the value of displacement from O to B? From O to B it is moving, and this is known as displacement, and we can easily count by using this two approaches. First one this one, second one is this one. Okay, we can easily calculate. So shifting means distance between initial and final point. Shortest distance is known as displacement. It is fine, it is for definition, but the separation between initial and final point, or gap between initial and final point, this is known as what? This is known as displacement. For numerical problems it will be very helpful for you. Okay, in the next class we will discuss about speed and velocity in detailed way. So I think this is helpful for you. If it is, hit the like, and okay, leave a comment if you have any doubt. I will discuss in the next class velocity and speed, and about the direction of distance and displacement also. So for this class, up to this, thank you.